Good morning, everybody, and welcome to the latest of Eurostat's webinars on, in this case, mastering map creation with Eurostat from data to visualizations. I'm John Verinder from Eurostat, and I'll be moderating our webinar today. I'd like to tell you that the event will be recorded, so you need to bear that in mind and be able to watch it later. We will have a question and answer session towards the end of the webinar after the presentations. And here we welcome your questions. We'll be using the Slido tool for collecting questions from you. So here on the screen you can see the Slido code, and also you can catch the barcodes as well. The Slido code to use is #2475313, as you'll see on the screen. So please do feel free at any time during the webinar to introduce questions. We will deal with all the questions at the end, but of course you can enter them as the presentations go ahead. So let's introduce our speakers today. We have two well-experienced Eurostat colleagues who will take us through mastering map creation in all its interesting aspects. So you'll see on the screen next to me Julienne Gaffouri. Julienne is a statistical officer working in GISCO tools, mapping and spatial analyses. And we're also joined by Joseph Davies. Joseph is a Geographical Information System programmer here at Eurostat. So you'll be in good hands with them today, and as I said, at the end we will come back for our question and answer session. So let's move into our first presentation of today, and I'd like to hand over to Julienne to talk us through computing driving time to healthcare services. Julienne, please.
Thank you, John, and good morning, everybody. So in this webinar, we are going to present what we hope is an interesting data story, starting with a user request and all activities related to the data collection, data analysis, and in the end, the data dissemination with the design of maps based on this data. So the objective here, the main thematic domain is to assess the accessibility to healthcare and education services in Europe. So our objective is to simply measure how far the population here is from these basic services. And we started these activities a few years ago, mainly to support a request from European Commission services for regional and cohesion policies. So in this presentation, we will be two speakers, as John said. I will myself focus on the data collection and the analysis part, where I will present a work which was mainly performed by my colleague Christophe Bredel. And then I will give the floor to Joe, who will give more detail on the data visualization, the map design, and the tools that we offer also to make such kind of map. So for the data collection and analysis, so to measure the accessibility to basic services, healthcare and education, what we need first and foremost is, of course, the location of these services. We started already in 2019, sorry, the collection of such data sets, which describes the distribution of healthcare and education services in Europe. In this data set, we describe each service as a point feature with X and Y location and a number of characteristics of these services. You can see here the list of properties that we have collected, and the specific one for healthcare and education, which relate to the capacity and a more precise description of the type of service which is delivered. As an information source, because we had some strong requirement in terms of reliability, we analyzed what was available at member state level, and we decided to focus on what we consider as the most reliable data sources, which are registries maintained by ministries in member states, either health or education ministries, or similar public or governmental organization which usually disseminate this information. So as you can expect, also we had some issue of heterogeneity from country to country. So we had quite a good challenge ahead to harmonize this data to see what could be comparable from one country to the other, and to integrate everything into a pan-European dataset. And on this map, you have an overview of what we have obtained, for example, in the region of Paris for education services, primary and secondary. Each service is represented as a red circle, and the size of the circle is proportional to the capacity of the service in terms of number of pupils. So you can see the little red dots, which correspond usually to primary schools, and the bigger one for secondary services. Unfortunately, we don't have this information on the capacity for all member states. As I said, we have quite some heterogeneity in the availability of the data, but in many countries, we are able to do such kind of map. And we have also some additional information on each individual service, such as the address, the name of the service, and so on. So this data is available on Eurostat website. We published it a few years ago. Here is a URL. We will share all the URL in the end of the presentation, so no need to rush and copy them. And you can find on Eurostat website different ways to download it in case you want to run specific analysis on this data set. We also have tried to document it as much as we could to describe the data sources and the possible limitation we have identified in these data sets. So we are aware of some strong limitation, and our idea was to be as transparent as possible on these limitations. So we did this activity to collect the location and very rich information on these data sets. And in order to compute the accessibility of the population, we also relied on existing Eurostat datasets, which describe the distribution of the population on a 1 kilometer resolution grid. So Eurostat is publishing such dataset for already several years. And recently we published, following the Census 2021 exercise, a new version of this population grid with also some breakdown by age group and other dimension. So with this dataset, we know where the population is with a rather fine geographical resolution at 1 kilometer. And the idea is, of course, to measure how this population can drive to the nearest service using the road transport network. And for that, we use a third dataset, which describes the road transport network and various characteristics of the road transport network, such as driving speed or the administrative classification of the road section. So what we run is something that we can do quite easily with Geographical Information System. It's a graph analysis algorithm to compute routing, to compute the driving time to the nearest services. So we have computed a number of indicators, which we published a few months ago on Eurostat website. So here is the URL. Here are some screenshots illustrating the spatial analysis. You can see here, for example, in gray is the road transport network and different what we call the isochrone from education services in the center as blue points, and you can see the different areas which can be reached from these education services driving 5 minutes or 10 minutes. Here on this screenshot, you can see also for different healthcare services in green, the different shortest routes to the population grid cells, which are represented in orange. So it gives you can see around each healthcare services a star structure, which gives an overview of the catchment area of each of the services. In such a way, you can also see how the algorithm computes this shortest path. And also it gives an overview of the different size of the catchment area for each of the services. So as a final result, we published a digital map here, which I can show only a quick screenshot on Luxembourg around the Eurostat premises. And you can see different shades of colors, which represents the travel time to the nearest services. We have also represented each grid square as a circle whose size depends on the population. So it's a way to to visualize together both the population and the travel time. And in such a map, what you can easily see is the fact that the main population clusters, usually the cities, have quite a good accessibility in for the healthcare services because they appear blue. It's quite expected because most of the services are located in cities, of course. But you can see also in red some of the areas where you have some significant population clusters with a poorer accessibility to these services. You can see, for example, in the north of Luxembourg and also between Cochem and Koblenz, some areas where population need to drive 30 minutes and even more to drive to the nearest hospital. You can see also some interesting structure. In the north of Verdun, you have some areas with sparsely populated areas where the healthcare services are not so present. And you can see in this area as well some specific issues and maybe some need to develop better the accessibility to these services. So on this other threshold, we illustrate the fact that we computed this indicator for 2 years, 2020 and 2023, which allows us measuring the evolution of the accessibility across these 2 different years. And you can see on this area in Germany, in the north of Stuttgart, that we could measure some areas in the north here in red where the accessibility has decreased because you need more time to drive to the nearest hospital, while here in the north you have a blue cluster which shows an area where this accessibility has improved. So this could be explained either by a change in the distribution of the services. Maybe an hospital has closed or disappeared from the data set. Another one has been created, but it could also be due to an improvement in the road transport, because of course, when you improve the road transport network, you improve the accessibility to the services. And here is another map we could produce at the European scale, where we could aggregate this indicator at grid level, but at more typical statistical units, the NUTS 3 regions, where we could compute the share of the population which lives within 15 minutes of the hospital. So it shows at NUTS level and at the European scale some interesting heterogeneity between the different regions and between different regions of Europe. Okay, so I'm not going to present more into detail about the map. I'm finished with my part of the presentation. Now I will give the floor back to Joe for this this next step of the analysis. He will present to you how such maps are made, how we will use some tools, GridViz and Image, to make these maps, and how these tools support quite an advanced exploration of the data sets and are quite informative for the users. So the floor is yours, Joe.
Thank you, Julien. Good morning, everyone. I will be quickly going through the final chapter, if you will, of the data to map story, which is essentially the interactive vision of the map Julien just showed. So without further ado, I'll get into it. First of all, I just want to start by saying that all of the maps that I'll be showing were generated using open source software that was developed in-house at Eurostat, which will be published in the Slido at the end, along with the links to all the maps. So this is the interactive vision of the accessibility map that Julien just mentioned. So we have panning, zooming, and the idea is to have a multi-resolution approach. So when you're zoomed out, you see the coarse resolution, you see the largest grid cells, so say 50 kilometers zoomed out at a European extent. And as you zoom in, you progressively get a finer resolution. So you get the general trends at a European extent. And as we zoom in, we can see the detailed, finer, granular data. So essentially the idea behind having an interactive vision is to enable users to interact with the data set, to explore the data, We have a tooltip to instantly access the statistical values. We have options to switch between healthcare or education. And we have the different years available, as Julien mentioned, and we also have the option to see the drive time to either one service or 3 services. So you might want to investigate that. We have some of the typical options in your map views, the city names, the boundaries. And we also have some more advanced cartographic techniques, which I'll go through. And I'll also go through the software that it was made with in a moment. But first, I'll show you this option, so we can show what are called Tanaka contours. So this essentially gives a sort of elevated impression of the data of groupings. So it lets us sort of see these islands of inaccessibility. And a term I often use in cartography is misleadingness. So we want to avoid misleadingness in maps wherever we can. A map might not essentially be incorrect, but it might be misleading to a certain extent. An example of this is, for example, in Spain, you can see there's lots of red on the map, but it might be to a certain extent misleading because there might not be anyone living there. So we can adjust the size of the cells by their population, and you can see that there's a lot less red on the map now. So we're giving sort of less visual importance to areas that aren't populated, essentially. In fact, for those who are familiar with this famous visualization a couple of years ago called Land Doesn't Vote, it's essentially the same concept. So it was, I think, an election map where each state was colored in a certain color, but it was essentially misleading because land doesn't vote, people do. So in this case, it's, we're not mapping land, we're mapping people. So we try and remove any misleadingness where we can using certain cartographic techniques. And also, if you're as nerdy as I am and spend hours going through this data set, then you can also enable dark mode, so it doesn't strain your eyes as much. Okay, so as I mentioned before, this was made using a library called GridViz, which we've developed ourselves at Eurostat. It's available on our GitHub page, but yes, I'll post all the links in the Slido afterwards. It was developed in order to visualize, these massive statistical grids with millions of cells on the fly in the browser. So we need to be able to have this multi-resolution approach. We need to be able to control every single cell and the way it's drawn in order to apply different cartographic techniques that you can see on the screen now. And also, yes, we needed a tiled approach. So instead of loading the whole grid at once, we can load individual tiles for a more efficient experience. The software that generates these tiles from the grid is also open source, available on our GitHub. It's called GridTiler. So if you have, say, a CSV file of a 100-meter grid of wherever, GridTiler can slice it up for you and create aggregated multi-resolution grids. Okay, you might ask, why did we develop this if there's existing GIS software out there? Well, we needed, again, to have this controlled approach. We needed to be able to draw every individual cell efficiently on the fly in the browser. The reason why we developed this was we knew that the census was up and coming. We knew we needed to visualize the census data. So that's what we did. This is the census grid viewer that we've developed using GridViz. And it lets you explore all the indicators that come with the census. So we start off by sort of increasing the difficulty, if you will, of the map to the viewer. So the simplest indicator is total population. So the darker areas are more populated, the lighter areas are less populated. Again, fully interactive. You can zoom in to the finer granular data. And we also have the options on the left here to explore the other indicators. So here we have the share of women. So so greener, bluer areas, more women, red areas, more men. Whilst we're going through this, I'll share a couple of interesting patterns that we've discovered whilst going through the census data. One of them is Mount Athos in Greece. For those who are aware, here it is, all in red. So no women. So I will let you in your own time discover why there are no women on Mount Athos. But yeah, some interesting patterns in the data that can be explored using GridViz. The next one would be, and again, there are plenty of indicators, I won't go through them all, about age groups, about employment, residency, but one would be about this valley in Austria. I'll probably mispronounce the name, but I think it's Kleinwalsertal. So it's a valley in Austria where the only way to access it is via Germany. So it's essentially, yeah, cut off from the rest of Austria. But so if we go to the population that was born in the country, you can see that there are very low values for these cells. So the reason being that the closest hospital is in fact in Germany. So yeah, just another curiosity. The third one I'll show would be on the age map. So we have areas in red where there's an overrepresentation of people over 65 years of age. Green would be an overrepresentation of people 15 years and under. So we can see this this coastal phenomenon in France, where there seem to be higher concentrations of retirees on the coast, and yeah, lots of red in northwest Spain, Italy, Greece, yeah. But I'll leave you explore the data in your own time. Yeah, and then we also have sex, employment, age. So this is a different cartographic technique. You might be a bit confused about what you're seeing, but it's essentially, imagine a pie chart, but instead of a pie, it's a flag. So it's you can discover the different age compositions of each area, and again, multi-resolution. So as you zoom in, you get the finer data. Same with mobility. This time they are pie charts, and place of birth, half-tone technique there. Okay, so without further ado, I'll move on to the next map that Julien showed, which was a regional map of the healthcare data, which was created using our interactive map generator called Image. So there is another webinar that we did previously on how to use Image and all of the possibilities that come with the tool. So I won't go too in depth about what it's capable of. So if you are interested, there is a separate webinar available, but links will be posted in Slido, so you can explore it in your own time. But at the moment, I'll quickly recreate the map using the data that Julien mentioned. So we have CSV, which will look something like this, where you have one column for the NUTS codes and one column for the values. So in this case, it's the percentage of the population that are within a 15-minute drive time to a hospital. So I'll quickly edit the class breaks. As you can see, as soon as I upload it, it gives you a default color scheme. It gives you default class breaks. So I'll quickly edit them to so that it corresponds with the map Julien shows. We'll use equal interval, seen as the distribution of the map enables us to. Okay, so we need a title. So I'll go with the general theme of the map, access to healthcare. Subtitle, what was it, population living within a 15-minute drive to a hospital. 2023, I believe it was. Legend title would be percentage of population. And you can also see this circle on the map where it's pulled out the EU value from the data, so it's automatically detected. We have an EU value and it's put it in this this stamp. So once we have a map, we can also add some annotations, which is actually a new function that was not available in the previous webinar. So I can they had an annotation to a specific area of interest, and yeah, if I want to draw the attention of the reader to that specific area for whatever reason, then I can. So once we have our map and we're happy with it, and we've gone through, the help and the checklists that are available to sort of guide you through the map making process a bit and make sure you don't fall into any major pitfalls, then you can export your map as a PDF, a PNG, SVG, and also the interactive map that you see on the right here is also available as an export. So if you wanted to embed this in your website, for example, then it will package the entire interactive map along with the software that was made to use it, which I will get onto next. So the actual map, the motor of this mapping application, again, yes, you guessed it, is open source. It's available on our GitHub, and it is based on D3, and it's a thematic mapping library. So most maps made using Eurostat statistics that you will see on our social media channels will be made with this library. Again, feel free to reuse it. Feel free to get involved, contribute. If you're a data journalist, then yeah, be our guest. So I think I've covered everything, and yeah, I hope you enjoyed this little run through of the data to map story, so you get a bit of insight into what we do at Eurostat in terms of mapping and data and spatial analysis. And yeah, thank you for listening, and have a good morning, everyone.
Okay, thank you very much, Joe, and thank you very much, Julien, for the very interesting presentations, very colourful. So now we can move into answering some of the questions which have been put into Slido. Just to say at the start that we'll try to answer as many of the questions as we can, but if we can't get to them in the time, then what we'll do is we'll introduce some written answers into the Slido in the coming days. So if we don't manage to get to your question or answer it, or we need to add more information, then we'll put it into the Slido and you can then follow up subsequently. So as you can see, I'm joined by the panel of Julien and Joe. So let's have a look at the questions. There were two sort of similar questions coming. There was, can I use your data in my book, make visualizations of it, if I mention you as the source of data? And there's also another question which asks, if I use a map created with this source, how should I cite it in a paper? So here I'll hand over to Julien to deal with that. Julien, please.
Yes, for all the data sets we are used for this spatial analysis, they have some licensing constraints which are available on Eurostat website. So every time we have a download page, we have information on the licensing constraints. So it includes quotation, of course, and for the maps. So if your objective is simply to show a map, we expect, of course, that you cite Eurostat as a source, but it's usually a common practice. And usually, when you make such kind of publication, it's always good to be transparent and to quote your sources. So it should be a general practice.
Thank you very much, Julien. I think I'm back to you for the next question. The question was, what is the source of the service data? I'm guessing this was part of your presentation about education and health services. So what is the source, please?
So yeah, as I said, maybe quickly in the presentation, when we started this activity, we found different data sources for it. Because we had some very strong requirement in terms of reliability, we found out that the most reliable data that was available was the one held by ministries in member states. If you go on the health ministry of whatever country in Europe, you will find some information if you dig a bit on existing registers which describe, for example, healthcare services. And this information is usually maintained by these ministries, and they are quite official because, as you can imagine, if in all European countries, if you need to practice medicine, you need some kind of approval by a governmental body. So that's why you have such registers that exist. And it's also for us a data source which met our requirements in terms of reliability. It's usually very well described. You have a good documentation of these data sets, and that's why we relied on them. So it doesn't solve, of course, the issue of heterogeneity and the difficulty also to access to this data. Sometimes it's poorly structured. That's why we had to do a lot of work to extract this data and to make it usable for our use case. But yeah, at least to answer to the question, our data sources are the ones that are documented on the metadata file of the data set. It's usually governmental sources in the ministries.
Thank you very much, Julien. Actually, that also covers broadly the next question about data sets available for communication. Julien, another question for you. I think you're quite busy at the moment. So question is, which software or GIS infrastructure was used for the accessibility analysis? And I think that links to another question on the list in Slido, which is the one about what software is used for visualization and calculations. So if you could answer those two together, please, about the software.
Yeah, we use a number of different technologies for the various steps in the process. Usually for all GIS data manipulation, we were using QGIS. And for the computation of the routing, we used PG routing and also a Python library called Network X, which is quite efficient and includes quite a large list of different graph analysis algorithm. Yeah, usually we try to be as flexible as possible for the choice of the technologies, depending on the type of indicator we want to compute. We have found out that we need to take care of the algorithm which is behind to be efficient enough, and also we need to ensure some reproducibility of what we do. So that's why we try to rely as much as possible on open source software, so that we can control the algorithm and we can also share the methodology with our users.
Thank you, Julien. There's a very nice question now, which is, do you account for the type of hospital? Living near a dental hospital may not be much use if I'm having a heart attack. Please go ahead, Julien.
Yeah, so that's one of the major issues we encountered indeed for healthcare services, a bit less for education services, but yeah, for healthcare services, it's there is no harmonized definition of what is a hospital across Europe. And in most of the registers we retrieved from health ministries, we had quite a high heterogeneity in the way these services were described, the granularity, and also the level of aggregation of them. For some countries, we could find a very high fragmentation of these services. For others, it was more aggregated. So our option for the accessibility was to filter out what we could call the less important services and to focus only on the main services, which usually are a cluster of a high number of medical specialties. Usually it includes also an emergency service, and that's what people usually identify as a hospital. But of course, yeah, there is a continuum between what we could call the hospital and what we could call the medical center or something like that. So at some point we had to draw some line to dissociate different kind of services. But yeah, to answer to the question, yeah, we took care of the fact that the dental service medical center was not identified as being a hospital, and we did some filtering for that.
Thank you very much, Julien. Although one would hope that a dentist could also do a little bit with a heart attack, perhaps. Let's move on to question 7, which is on the list, which is, which routing data is used, and is this data also available for subsequent use? Julien, please.
So for the routing, we used as origin point the services, which is available on Eurostat website. And for the destination, we use a population grid cell, which is also available. In between, we use a World Transport Network, which is unfortunately not fully available. We use a dataset called Multinet Air, which is a dataset used on TomTom GPS navigators. And for this one, unfortunately, we have some very restrictive licensing conditions. We cannot disseminate it freely, but we hope in the future maybe to opt for more open solutions so that we could also share this part of the data.
Thank you very much, Julien. So you've been very busy up until now, but now I'm going to start handing over to Joe for some of these questions. Joe, the first question for you on this list is: has GridViz support for different CRS? Perhaps you can tell us what CRS is, please.
Yeah, so by CRS, they mean coordinate reference system. So the answer is yes, but the underlying data in GridViz is actually X, Y, and statistical value. So if you have any data that is X and Y, then GridViz will support it. It will simply visualize the coordinates that your data comes in both CSV format and GeoPacket. So the answer would be yes, any CRS would be supported.
Thank you very much, Joe. That's very good news. There is a question about downloading maps once created. I think you covered that in your presentation already. So perhaps let's skip that one. And let's move on to another sort of more software-based idea. Can GridViz be integrated into any browser-based application like Tableau, SAC, etc.? Please, Joe.
Yes, anything is possible. The only restriction would be potentially on their end. There are no restrictions on our end. So if it is rendered in a browser, then yes, it can be ingested into any browser application. I don't know the specifics of Tableau or SAC, but in theory, it's possible if they allow you to.
Very good, thank you. So to give Joe a little rest and go back to Julien, we have a question on where can I find the data used in the gridded map. So I'll pass to you, Julien. I think you mentioned data earlier on and data sources, but please, if you could come back on this, thank you.
Yes, so most of the gridded data we have shown, both the population and the accessibility grid, are available on Eurostat website. There is a section on GISCO website on accessibility, and there is another one on population distribution, which is called Geostat. And there you can find different ways to download it in various formats. And also, as I said in the first question, the licensing constraint for these data sets. So it's on Eurostat website. We hope that it can be found easily. We try to make it as accessible and easily fundable as possible.
Thank you very much, Julien. So they're coming thick and fast, the questions, and we have a few minutes left. So let us move on to a question about gaps. Somebody saw gaps in the map for Finland and Portugal. Is that an error? Joe, please.
Gaps in Finland and Portugal. I'm not sure about that one. So it might be to do with the fact that the nuts regions might be corresponding with a different nuts year. In that case, it's just a question of changing it to the corresponding year. This is actually an issue that will be done automatically in the near future in image. So yeah, it's an improvement we need to make.
Great, thank you, Joe. So that's a kind of a follow-up. There are several questions here about regional or country maps. So can the image map generator be used only for a country? Can the image be used to create regional maps rather than the whole of the EU? If I want to use a country map, Portugal, can I do it? Joe, please.
Yes, so in image, there are various map templates, and included in those are specific countries. So if you had regional data for a specific country, you could create a map of that specific country and its outermost regions, its overseas regions. And we also support world maps in the Robinson projection. So yes.
Very good. Moving through with another couple of questions left, which we can take. Let me pick a couple which are a little bit different from the questions before. So one question for Julienne. Do you distinguish between public and private hospitals?
So in our data model, we have a property for each healthcare services to distinguish between public and private one. But unfortunately, this information was not available for all member states. So we have some gaps for this information. We also have some countries for which we found information only about public hospitals and not private one. And we have also the tricky case where some hospitals deliver both public and private services. So it's a bit tricky, but for accessibility analysis and the selection of the hospitals, we try to select the main healthcare services cluster, whether they were public or private. That was our choice for this analysis. But indeed, in the future, that would be extremely interesting to map the evolution of this, if there is some privatization that is developing in some countries, and also how it affects accessibility. That's more perspective, but indeed that's something we have in mind and that we hope we will elaborate on in the future.
Thank you, Julienne. I think we have time for one more question. There are a number of questions here, but as I said, for most of them, the remaining ones we'll come back in writing in Slido in the coming days. So the last question I saved for the end is for Joe, actually. Any good recommendation for underlying mapping guidelines more than the checklist on image? So, can you give us some general good recommendations, or is everything there already? Please, Joe.
So yes, in fact, included in the help section is a presentation, a wonderful presentation by my colleague Julian on the principles in map design, specifically thematic mapping. Apart from that, if you are interested in mapping statistics, I would recommend reading up on a cartographer called Kenneth Field. He has some books on cartography and thematic mapping. And also, I would recommend investigating, I'll probably pronounce it wrong, but Berton and his visual variables. So that would be my advice to any up-and-coming map makers.
Thank you, Joe. In fact, there was also a question about advice to people interested in becoming map makers. Also a good question there. So you've given a good reading list to start for that. Okay, it's been really a very lively session. I thank everybody very much for the questions which have been asked. As I said, those questions we didn't get to, we'll try to put some written answers into Slido as part of the follow-up. And I think Julienne and Joe both mentioned that we would have links available as well. So if you need the links, etc., in the presentations, you'll be able to follow those up. Before I close and thank everybody, I'd like to sort of mention that, of course, if you want to follow up on any rather more specific and detailed questions in this area, we have a multilingual user support for further questions, and the address will be posted in Slido if you want to follow up in more detail. And then I'd like to thank very much to both of the speakers, Julienne and Joe, for their interventions, the presentations, and the great answers to the questions. So thank you very much, gentlemen. And just to announce for the future, on the 6th of June at 10:15, there will be a webinar on the Sustainable Development Goals. So those of you who are interested in this, please join us on the 6th of June, and you'll find more information on that on Eurostat's website. So once again, thanks to everybody, and we'll close it off there on time, and have fun with making maps is all I can say. So goodbye, everybody.
Bye-bye. Thank you.
Goodbye.